Hi everyone, welcome to the channel. Today we'll be looking at this problem called generate parentheses. And in this problem statement, we're given n pairs of parentheses and we want to write a function to generate all combinations of well-formed parentheses. So here we see there's an example of n equals 3 and there's our solution set. And so let's say that we receive this question on an interview and they don't give us an example. Then the next best step would be to write out an example that is with a reasonable size n. So I think for this problem, n equals 3 or n equals 4 is a big enough test case where you can find patterns and be able to solve this problem. So another example is maybe they might give us a test case and they just tell us n equals 1, or yeah, n equals 1, and then they draw one opening parentheses, one closing parentheses, and then say, hey, that's the solution. But that example is so small that you might not see the pattern. So even if they give you a test case, if it's small, you want to just write out a big one to help you find a pattern. So now that we have this n equals 3, we see that for well-formed parentheses, you have the same number of open parentheses as closing. So each of these, they have 3 opening and 3 closing because n equals 3 and we have 3 pairs. The other thing to notice is that if we go from left to right, each time for each indice, we have more opening parentheses than closing parentheses. And the reason why this happens is that if we have more closing parentheses than opening, let's say we start like this, it doesn't matter what is afterwards, it will always be non-well-formed parentheses or a combination of parentheses. So with that being said, noticing that pattern, we will be able to move on to our main idea, which is that for each indice, so let's say we have n equals 3, then we know that the combination, if it's valid, it will be 6 elements. So from 0 to 5, 0 indexed. Each time we'll start from left to right, and we will add one closing parentheses if it's valid, and also one opening parentheses if it's valid. Now for the combination to be well-formed, there has to be 2 conditions that are satisfied. One is that the final combination of parentheses has the same number of opening parentheses and closing parentheses, which we stated before. So here's the 2 cases, or 2 conditions for well-formed parentheses. 1, open parens, close parens equals 2 to n. Our second condition is each time add a parenthesis, we will open parens greater than close parens. These are the 2 conditions. And once you reach 2 times n, then we will be able to add that current combination into our list of results. Yeah, so from here, our main idea, we can write down main idea, which is to add open parens if valid to current combination, add close parens if valid to, not to, but for, append current combination if reach 2 times n size. So with this being said, we can see that we have enough to work with to code. So we can start off with these comments, and the first thing is we need somewhere to store all the results. We see that we have a list here of results of valid well-formed parentheses. So we'll call it well-formed. We'll make a list so that we can append it later. And because we made that, we know we want to return it in the end. And we'll use some helper function to do the rest. And now what this helper will do is all of this stuff. So we'll put this in here. And what we notice is that for the well-formed conditions, we need to keep track of open parens and closed parens. So what we can do is we can have 3 arguments. Let's do the parameters. We could call open parens, closed parens, and current. The current will be the current combination. Open parens will indicate how many open parentheses we have in the current combination so far, and closed parens will indicate how many closing parentheses we'll have in the combination so far. And then so for the beginning, we know that initially we will have nothing, an empty string, and there'll be no open parens or closing parens. So that's our helper function call. And then we see that if we have 2 times n, then we will append to the well-formed. So we do if 2 times n equals open parens plus close parens, well-formed dot append current. Next we add open paren. Now we have to think about the fact that anytime we reach 2 times n for the length of the combination, we are going to append that, meaning that all the recursive calls must only be called if there's a valid insertion. So when we add an open parens, we need to understand when the open parens will always be guaranteed to be valid, and that is if we have less than n number of open parens. Because if we add more than n open parentheses, then and we will end when the combination is at 2 times n, then there will be too many open parentheses. So if open parens less than n, then we can call, and when we call the helper, we will add to the open parentheses, and we will pass the result of close parens, and we will add the open parentheses to the current combination. Next, we have to think about close parentheses and when that function call will be valid. And we know that the close parentheses is valid if we have more open parentheses than the closing parentheses. When there's more open parentheses than closing parentheses, we know that adding will be valid because the case that there are more close parentheses than open parentheses is invalid, and each recursive call is going to be valid. So the way we ensure that this function call is also valid is that if there's more open parentheses than closing parentheses, for this case, we add another closing parentheses, and it will not cause the closed parentheses to exceed the open parentheses count. So we use an if condition. Continue to pass the open parens and then close parens, we will add one. And then we will add the closing parentheses to the end of the current. And we see these two conditions are essentially these here. So go to make sure it's good. So we have well formed, and then calls the helper function 0, 0, empty, and then well formed here returns at the end. Open parens, close parens, current, and then 2 times n, it's up here, open parens plus close parens. Then we append the current to well formed. And then if the open parens is less than n, we'll be able to add the open parens plus 1 and then close parens. We'll pass that and then the current added to open parens. Open parens less than n. Then if the open parens is greater than close parens, we will be able to add a closing parentheses. All right, let's see, running it, see if it works. Looks like it's good. Let's submit. Also, looks like submitting works. And so for the runtime, we see that we have 2 times n positions. And then for each of those positions, we check by adding a open parentheses and a closing parentheses. We have 2 possibilities, open parentheses, closing parentheses, and then there's 2 times n positions. So the runtime 2 to the 2 times n, which in big O notation is 2 to the n, where n is input. And then space complexity, we need to have space for all the pairs, so it's 2 times n times some like k, where there's k solutions. The solution is just dependent on however number of n. I'm not sure how it scales, so that's a little bit beyond, but overall it's O of n with the assumption that k is not very large. Alright, well, that's it for today. Thank you guys all for staying to the end. Like and subscribe if you want more content. Also, this explanation is also on my website, and the link is in the description below if you want to check that out. If you already watched this and you want to review, please check out the website blog post, and I have other resources for other videos on this channel on that website, so please do check it out and share with anyone you think will enjoy it. And yeah, I hope you guys had fun and learned as well, and enjoy the rest of your day.